Okay, the second video in 8.3, we are going to be looking at De Moivre's theorem again to find the roots of complex numbers. It's the final video. Nth roots of complex numbers. So as we already know, if z equals r cosine theta plus I sine theta, or we know that also in the CIS form, and n is a positive integer, then z has n distinct nth roots. So remember last video we looked at powers. This one we're looking at roots. Okay, so for it says now if k equals 0, 1, 2, all the way through n minus 1, i.e. if you have the cube root, so n equals 3, so n equals 3, the complex number has 3 distinct roots. All right, for k equals 0, 1, and 2. So you guys actually have to think about that. If it's to the third root or cube root, the 3 distinct roots are actually 0, 1, and 2. Not to be confused with before, or students thought that it was 1, 2, and 3. You have to include 0. So if it's cube root, you'd say 0, 1, and 2. If it was fourth root, you'd say 0, 1, 2, and 3. That's 4 roots, but you have to include 0. So that's why we talk about n minus 1. So 3 minus 1 is 2, 0, 1, 2. All right. Here's the formula w sub k for the nth roots. It equals r to the power of 1 over n times cosine of theta plus 2k pi over n plus I sine of theta plus 2k pi over n. Or here's the CIS form. I'm going to make this very, very easy for you guys. We're going to talk about a few things down here with the helpful tips, but I'm going to give you one thing. It's called home plate. That's going to take care of this. All right, so helpful tips. Number 1, the modulus or the radius, as we already know, the modulus or radius of each nth root is r to the power of 1 over n. Make sure you see that. That's the very beginning of the formula. All right. It says, number 2, the argument theta of the first root is theta over n. So that's the very first part. That says the argument theta of the first root is theta over n. All right, so you can see that's kind of like this part right here. And that is because k is actually 0 for the first one, for the first root. So if this k right here were 0, if that k were 0, it makes this basically go away. So all you're left with is theta over n. So again, number 2, the argument theta of the first root is theta over n. You're going to have to know that for what I'm about to talk about next. Then we repeatedly add 2k pi over n to get the argument theta of each successive root. You already have the 0, and then you get 1 and 2. You're going to keep on adding this. I call this home plate. Now, you're going to have to listen very closely here, all right, because I've made this up. It's called home plate, all right? So if I make home plate, this is what you guys can make every single time. It represents what you're going to repeatedly add every time, all right? So if you think about k and the first one being 1, well, that just leaves you with 2 pi on top. So 2 pi divided by whatever n is. All right, and so we'll get to this, but whatever n is, that's what you're going to divide by. So if I just go to the next page real quick, if n were, let's say, in this case, the fourth root. So if n is the fourth root, I would just put 2 pi over 4. That would be my home plate. All right, working backwards, this next one, it asks for the cube root. So home plate will be 2 pi over 3. All this is going to make more sense how you use home plate. But for now, make sure you always have 2 pi over n. That is each successive root that you add. This can be very, very simple. We're spending a couple days on this, but it can be very, very simple if you understand about 2 pi over n. Okay, let's get to a few examples. Okay, so this one says, what is the cube roots? It says find the indicated roots and graph the roots in the complex plane. All right, so it says cube root for 1 plus I. Okay, no problem. Let's just write down a few things. We know n. It represents your root. N is 3. Since we know n, I make home plate immediately. All right, so I'm going to make home plate. And it represents 2 pi over n. In this case, it's 2 pi over 3. That's what you're going to add every single time. We'll talk about the common denominator, everything in just a second. All right, now let's go ahead and find the tangent of theta. Tangent of theta, as we already know, is b over a, so 1 over 1. So tangent theta equals 1. And now since we know the tangent theta equals 1, we can now find theta. Theta equals pi over 4. We already know that from the unit circle. Okay. Now from there, let's go ahead and talk about r. Let's talk about how we find r. Remember that from r equals the square root of a squared plus b squared, no different than before. So 1 squared plus 1 squared equals square root of 2. And so there's r. And now these two things are very important, just like they were before. Now let's go ahead and write our rule using our rule W sub k. All right. So let's go ahead and find it. W sub k. Keep in mind what k represents. I'm going to go back so you guys can see that. Here's k. It's 0, 1, and 2. All right. So let's first find W sub 0. So W sub 0 is going to equal r, which we know is root 2. Now I'm going to put that as a rational exponent. So instead of the square root of 2, I'm going to put 2 to the 1/2 power. And we raise that to the 1 over n, which is the 1/3 power. We take that times the CIS, and then we know that theta is pi over 4. Pi over 4. And then right here we put plus. Now if I was going to do this without home plate, I'd put plus 2k pi. In the place of k, I'd put 0, and I'd be left with nothing. So it'd be 0. So I don't really have to actually add that, and I'm not going to. So I'm just going to show you the way that I do this, and I've always taught it. All right. I still need to divide by 3, which is n. Instead of dividing by 3, I'll multiply by the reciprocal, which is 1/3. And this will give me W sub 0. So I'm just going to clean this up. So W sub 0 equals 2 to the 1/6 power CIS pi over 12. That is actually one of your answers. I remember we're going to have, it's the cube root. We're going to have 3 answers: W sub 0, W sub 1, and W sub 2. Okay, now let's find W sub 1. From here, it's no problem. Now, home plate, remember, here's where it becomes important. After I get W sub 0, W sub 1 and W sub 2 are no problem. All right, so how do you find W sub 1? W sub 1 equals still 2 to the 1/6 power CIS, but now it's going to be pi over 12 plus home plate. Now, home plate was pi over 4, or excuse me, pi over 3. But what I'm going to use, I'm going to use the common denominator. So I'm going to multiply home plate by 4, get a common denominator. So really my home plate is 8 pi over 12. So right here, I'm going to add 8 pi over 12. And so finally, and I have W sub 1. W sub 1 is equal to 2 to the 1/6 power CIS. If I add 9 pi, or excuse me, pi plus 8 pi, I get 9 pi over 12, which simplifies to 3 pi over 4. There is W sub 1. And finally, we'll go ahead and we'll find W sub 2. That'll be the last one. W sub 2 W sub 2 equals, still we have 2 to the 1/6 power. I forgot the equal sign there. Should be equals here. W sub 2 still equals 2 to the 1/6 power CIS, and then again I'm going to add home plate. All right, every time we add home plate. So I'm going to use the previous answer, W sub 1. W sub 1, not sure how that didn't show up there. W sub 1. I'm going to add 8 pi over 12 to 3 pi over 4. All right, so I want to add 3 pi over 12. Excuse me, I want to add 3 pi over 4 and 8 pi over 12. Again, I need a common denominator. If I get a common denominator, I will if I get a common denominator, I'm going to have 3 pi over 4. I'm just going to do that work kind of right here. 3 pi over 4. Actually, I'll do it here. I'll get a common denominator with 12, so I'll multiply top and bottom by 3. That gives me 9 pi over 12. All I do is get a common denominator here by multiplying top and bottom by 3. 9 pi over 12. And then I'm going to add home plate plus 8 pi over 12. And so what is W sub 2? W sub 2 equals 2 to the 1/6 CIS 17 pi over 12. If I could simplify that, I would, but I cannot. And so there is my third answer. Now, let's find the indicated roots and graph the roots in the complex plane. The modulus radius of each nth root r to the 1 over n. It would end up about right here, something like right there. That's all we're looking for you to do. Okay. Watch the video again if you need to. I have a second example. So the fourth root of 16i. The fourth root of 16i. If I were to graph this right away, it says the fourth root of 16i. Well, that would just be up here. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's up there. It doesn't look like it's going to fit. Not from the graph that I have, but it would be up here somewhere. Okay, just keep that in mind. 16i is up there. Now let's get on with this. So fourth root, I'm going to start with home plate. Home plate is 2 pi over n. In this case, 2 pi over 4. Then I want to find W sub 0. So to find W sub 0, I first need r and I need theta. Okay, no problem. Let's find r. That's no problem because the radius, we don't even have to use the rule. The radius to this point, the radius, that length is just 16. That length is just 16. Then to find theta, we could do tangent theta equals b over a, but you should know what the tangent is, or you should know what the angle theta is to this point here. Theta is just pi over 2. All right, this angle is just pi over 2. Great. Now we have theta and we have r. Let's go and start finding W sub 0. So what's W sub 0? W sub 0 equals r, which is 16 to the power of 1 over n. 1 over n. N is 4. I could put that up here too if you wanted. So your root. CIS. And remember, all I really want, if k is 0, that part goes away. I don't need that. All I need is theta divided by n. So what's theta? Theta is pi over 2. Divided by n, I'll multiply by 1/4 instead of dividing by 4. So what's W sub 0? W sub 0 equals 16. And actually, I can clean that up. 16 to the 1/4 power is actually 2. CIS, pi over 2 times 1/4 is pi over 8. There you go. Let's find W sub 1. I already see that this previous one was pi over 8, so I'm going to get a common denominator on my home plate by multiplying top and bottom by 2. So it's 4 pi over 8. And now I'm going to find W sub 1, I'm going to do 2 CIS. That part stays the same. And I'm going to do pi over 8 from the previous W sub 0 and add 4 pi over 8. So I get 5 pi over 8. Final answer. If you're wondering where I got the 5 pi over 8, it was 4 pi, my home plate, 4 pi over 8. All I did was I added it to the pi over 8. Finally, we do it one more time, or 2 more times, to find W sub 2 and W sub 3. W sub 2 is 2 CIS. Now I'm going to add 4 pi over 8 again. And it just gives me 9 pi over 8. There you go. Last but not least, W sub 3. W sub 3 equals 2 CIS. Again, add 4 pi over 8. my home plate gives me 13 pi over 8. And there are my 4 answers. It's a little bit easier as you guys keep on practicing. The last one might have been really confusing, but you can see how we kind of knocked this one out with no problem. De Moivre's theorem makes this formula a lot easier. And even with that, if you can remember home plate, that makes things much easier as well. Okay, so I want you guys to go ahead and do this one. I'm going to show you a little something first because I want you to do it on your own, and then I'll show you the answer. This right here is just says, okay, z to the 4th equals 1. So if I subtract 1 on both sides, I really just have z to the 4th equals 1. So really what it's saying is the 4th root. So I solve for z, it'd be the 4th root of 1. If you can't understand that, 1 plus 0i. Okay, so go ahead and do a few things. Find n, r, and theta. So find n, r, and theta, and then find home plate. Okay, go ahead and pause and try to do this one on your own. Find w sub 0, w sub 1, w sub 2, and w sub 3. Okay, here's what you should have gotten. And I'm just going to write down home plate right away for you, in case you didn't. Home plate should have been 2 pi divided by 4. 4 because the 4th root. Take a look how easy this one was, though. R, the radius. If you're going to graph this one, you know, it was just 1. So 4th root of 1. 1 is right there. And so R, that radius was 1. Theta at that point is 0. Theta is 0. And then theta was 0. That angle is 0. And so now let's just go through it. How did I get this? W sub 0. Now, what's R? R is my radius of 1 to the power of 1 over n, in this case, 1/4. Well, 1 to the 1/4 power is still 1. So you see 1 out in front of all these. All right. CIS of theta. So W sub 0 gave me 1 CIS 0. All right. Make sure you guys are clear that R, my radius, 1 to the power of 1 over 4. It's like the 4th root of 1. It's still 1. All right, that's why there's just a 1 out in front of the CIS. Let's do W sub 1. W sub 1, all I did here is I added home plate. Now, home plate's 2 pi over 4. That simplifies to pi over 2. All right, so I just added pi over 2, and I got W sub 1. Add pi over 2 again. Pi over 2 plus pi over 2 just gives me pi. And one more time, add pi over 2. Get a common denominator. This would be 2 pi over 2. I got a common denominator, which would give me 3 pi over 2. And there's all 4 of my answers. That is it. That you guys have all learned everything that you need to learn for the entire year of your last section. Let us know if you have any questions, and let's get prepared for the test and do really well and finish off the school year very nicely.